So I asked you guys to initially think about how you would set this type of polynomial division question up, but before you think about this one, I want to take a little brief detour and go back, and we're going to think about what it would look like to take 5,000s, 700s, and 3 ones and divide it by 110 and 7 ones. What would that look like? Well, if I wanted to put that into an algebraic sentence, I would say that I'm going to take 1 and 7, which is going to give me 17, and divide it by 5,000s, 700s. Uh-oh, it almost looked like there's something missing right there. What would have to go there? Well, we would say I should have 10s written there. I have no 10s. Oops, I would have completely forgotten about that if somebody hadn't brought it to my attention. Okay, so 0 10s and 3 1s. So I'm taking 17 and I'm dividing it into 5,703. So we're going to use this idea of filling in those missing components when we work this question so you don't accidentally make a mistake. So let's look here. I've got a fifth, a third, a second, and then I have one that has no ends in it at all. So that means that I have 3n to the fifth plus, there's somebody missing right here. So plus 0n to the fourths. So that was one of those hiding ones. Plus 4n to the third plus 5n squared. And then, oh, there's another missing term right there. So we would need that guy also. Plus 0 n's, and then plus 4. So making sure that I remember where there might be missing terms. So a lot of kids make that mistake. They forget to look for their missing ones. So make sure you watch out for that. So now I can divide. We can do this one. This one looks like it's going to be long, kind of gnarly. So I'm always going to be dividing my first term into the first number. So this guy just kind of comes along for the ride, but what we're doing is how many of these go into whatever the term I'm interested in. So how many n's go into 3n to the fifth? Well, 3n to the fourths do. And you might be tempted to just multiply it here, but we need to multiply it to both of them. I'm going to multiply through and then subtract. So 3n to the fourth times n gives me 3n to the fifth minus 9n to the fourth. So it's just some long division there. These will always go to 0 because we designed it to do that. And then I'm going to subtract negative 9 from 0. 0 minus negative, be careful, plus 9n to the fourth. Don't forget to drop your number, plus 4n cubed. So how many n's go into 9n to the fourth? So now we're going to be checking this guy against this guy. Well, that would be 9 n cubes go in. I'm going to multiply through. 9n cubed times n is 9n to the fourth. And then times negative 3 is negative 27n cubed. This looks like it's going to get pretty ugly pretty fast, but that's okay. Subtract, that makes 0. I minus negative 27. That's going to give me plus 27, and 4 is 31n cubed. And then you drop this number down, plus 5n squared. N goes in to 31n cubed, 31n squared times 31 times n gives me 31 n to the third plus minus, I would make that minus 93 n squared. Now I get to subtract again. Ooh, these numbers are getting big. There's that, makes 0, and then minus negative makes plus. So now we're all the way up at 98n squared. And now we're bringing down that 0n. Now you can see these numbers are getting pretty big pretty fast. So n goes into 98n squared, 98n times. That's going to make 98n when I multiply this term by this term. And then 98 times 3 is 6 less than 300, just 294. You're welcome to correct me in the comment section if you want. You'll notice that I turned it off, therefore no corrections. Subtract. It's going to give me, oh, that guy's still negative. 0 and then 294 positive n. I'm going to bring down, oop, this guy's going to have to sneak around, plus 4. And then I would do that one last time, but this time the numbers are getting really yucky. Plus 294, because n goes into 294 and 294 times. And then I would multiply that through, and I would get subtract 294n minus 294 times 3 is going to be, we'll just put big. And so we're going to have a big remainder. You guys can do the detail work there if you want to. One more. This one's a little bit different because here I'm taking a quadratic and I'm dividing it into a cubic. So divisor on the outside. The dividend on the inside. Oops, that's supposed to be a 4. I copied it down wrong. 4 minus 3n plus 0n plus 2. You might say, well, where'd this term come from? Same thing as over here. It was invisible. It was hiding right there. Don't forget those zeros. So there are some cool things you can do with when you take a big long polynomial function and divide it by like a linear function. There's some neat tricks that we can do. For now, we're going to be doing long division, but here's the thing. None of those tricks work on quadratics into like a larger polynomial. You have to know how to do long division to deal with these. So even if you were to learn other tricks like synthetic division or synthetic substitution or remainder theorem, we'll look at some of those this year, some of them next year. But even if you learned those for these linear into polynomials, you still have to know how to do long division for quadratics into something else. So we're going to implement the same procedure. We're always looking to the first term and how many times it goes into these as we work through it, and then we distribute it back through. So n to the 4th goes into 4n to the 3rd, 4n times. I'm still going to take this guy, multiply it to each term. That's going to give me minus 4n cubed, and then plus 12n squared, and then plus 4n. And then this minus is because we're subtracting the whole quantity from each other. This is going to go to 0. We designed it to do that, so it should. Negative 3 minus positive 12 gives us negative 15n squared. 0 minus 4 gives us minus 4n. How many times does n squared go into negative 15n squared? It goes in negative 15 times. We're just looking for common factor there. Then we multiply through, and we get negative 15n squared, and then negative 15 times positive 3 gives us negative 45n. Here's our plus 2 from dropping our term. And then negative 15 times 1 gives us negative 15. I'm going to subtract the 2. We subtract when we do long division. That's going to give us 0. This is going to give us positive 41n. And this is going to give us positive 17. So when I get to this point down here at the end, I could say that the answer to this question up here is, I'm going to put the answer down here. Down here. The answer is that it divides in 4n minus 15, and you could say remainder 41n plus 17. That's kind of a weird one, but these ones that have remainders are always kind of yucky. You might see it written again with a fractional. Say that my answer is, it goes in this many times cleanly with 41n plus 17 over the original divisor, n squared plus 3n plus 1, with that being our leftover quantity. So that's like when we write something like a fraction, like we did up here, where we said that 596 remainder 15 is the same thing as 596 and 15 out of our original divisor, which was 30, which reduced to a half. So that's how that applies down here. We can't say and a half, so we show that they create one number together by putting the plus sign between them. Things to remember. Big ideas, you might want to put like do this one in a different color, or if you've been doing everything in black ink up to this point, things to remember. Don't forget to include the zeros. So that was like here, or up here when we did on this question, we had a couple of zeros. So one, don't forget to include the zeros. Be careful with your signs. What I mean by that is not like watch out for Tauruses or anything. What I mean by is positives and negatives, particularly when you're doing these subtraction. Kids tend to forget that we're subtracting negatives, so that's going to make a lot of positives. Or if I was just subtracting a positive, it's a normal subtraction kind of problem. Okay. And then last thing to remember, which is even though after today we're going to be doing lots and lots and lots and lots of these that don't have a remainder, in most cases, if I were to divide two things, I would have a remainder. So there's going to be remainders happen a lot. And what else about remainders? They tend to be messy. So we have our answer plus remainder. So this is like the whole number component over divisor. So the whole with fraction. That should be enough to get you through all of the practice in the next section. See you guys tomorrow in class.